Hey y'all, welcome back. I'm Mr. Boyden, and in today's video, we're going to focus on some vocabulary and some definitions relating to triangles and quadrilaterals. Now remember, triangles means they have three sides. Quad, that's four, so quadrilateral is four-sided closed figures. Let's start off with some vocabulary. Some of these are going to be, I think, fairly obvious. Okay, like for example, a right triangle would look like this. And a right triangle is any triangle that has a right angle. So a right triangle, I'm going to write that here, has a right angle. All right, and yesterday actually some of my students pointed out in class that means it has two acute angles. That's true as well. What about an obtuse triangle? An obtuse triangle is just same thing, it's a triangle that has an obtuse angle. And that does mean it will have two acute angles. But let me make that note. It has an obtuse angle. Okay, when we're talking about this category of triangles, or this set of types of triangles, the third one we might talk about is an acute triangle. An acute triangle, here's an example. It has all acute angles. So by that we mean no obtuse angles, no right angles. Now, why is scalene in here? I don't know why the curriculum put it in this order, but they did. Scalene just means that no sides are the same length. So no sides the same length, or you could say congruent. And so for that, I'll draw one out. Maybe I say that's 3, 4, and 5. You can see all three sides are different lengths. Down at the bottom, I want to fill in what an equilateral triangle is. I know it looks like I'm skipping over a bunch, but I swear I will explain myself in just a minute. An equilateral triangle, so remember equilateral mean equal side lengths. So that is a triangle in which all sides are congruent. That's kind of the opposite of scalene. Scalene was all the sides are different. Here, all the sides are the same, or I'm going to put the congruence symbol to show that fact. So for example, if I mark that all three sides are the same, that therefore is an equilateral triangle. Okay, now these other vocab terms that I kind of skipped over, I'm going to put a box around them because they all sort of go together. They don't all mean the same thing, but they're all used for describing an isosceles triangle. And an isosceles triangle is one in which two sides are the same, or they are congruent, and one of them is different. So I'm going to put one pair of congruent sides. So an easy visual for that is like two chopsticks standing up together. That's, you imagine a chopstick here, chopstick there, and then maybe a table down on the bottom. Now, let's put these vocab terms on this picture. The angle where the two chopsticks, where the two congruent sides meet, that's called the vertex angle. The side which is different from the other two is called the base. Down near the base is where the base angles occur. I'll highlight those for you. So I'm going to go like this, and I'm going to mark them here, and I'll write base angle on the side still in green so you can kind of color code them. Those are the base angles. And so that's all of our vocabulary for triangles today. Now we're going to switch gears just a little bit, and we're going to spend the rest of our time today talking about quadrilaterals, and we're going to talk about specific ones that you've probably heard of most of them, but maybe some you haven't, and in many cases I don't think you will necessarily know the true definitions of them. Okay, our first one is a trapezoid. And so what we have here on the left is three pictures of trapezoids, and on the right we have three pictures of things which are not trapezoids. So I do want to say again, every shape we're going to talk about now is a quadrilateral. So four-sided shape. So notice these three pictures. What do all three of them have in common? These marks indicate parallel lines. And notice each of these has two marks. That's one pair of parallel lines. So in our curriculum, that is the definition. There is an alternate definition that says that it's one or more pairs of parallel lines, but for this class right now, we are going to say a trapezoid is defined by having one pair of parallel lines. Or maybe I should say sides. I think that would be more descriptive if I called it sides of the shape. Okay, now what about these ones on the right? So what's wrong with them? This one has two pairs, so that's actually called a parallelogram. We'll learn about that in a minute. This one down here on the bottom right, or on the right side, it actually has five sides. 1, 2, 3, 4, 5. So trapezoids only have 4. And then, that's silly. That's a mousetrap. So no, that's not it. The next shape that we're talking about is called a kite. So here on the left, we have 3 examples of things which are kites. On the right, 4 examples of things which are not. Some of these are easy to dismiss as not being kites because they have too many sides. Like both of those have 5 sides. Those are pentagons. But what do all 3 of these kites have in common? Specifically, they have 2 pairs of adjacent congruent sides. Now, if you don't know this word adjacent, adjacent means next to. So an easy way to think about this is if you're sitting on a couch with somebody, you're sitting adjacent to them. If someone is on the other side of the room, you might say that you are sitting opposite from them, okay? So next to is your easy way to understand this. So next to. Now, what does that mean on one of these pictures? What that means is, if I look at this side right here, this side that's adjacent to it, the one that's congruent, the reason it's adjacent is because they meet up. They're right next to each other. So that's an adjacent side. I'm going to highlight in green what would have been an opposite side. So this is opposite because to get from this side, you would be looking across the shape, not next to. But notice, from this green one, the one I have not highlighted yet, they are touching and they share the same marks. That's what we mean by adjacent congruent sides. So what about these ones on the right side of the page? What's wrong with them? This one, it does have adjacent congruent sides, but all 4 sides are the same. Specifically, that's actually called a rhombus. We'll get that definition in a second. And in this one, the opposite sides are the ones that are congruent. But for a kite, they need to be the adjacent sides, which are congruent. Okay, I mentioned parallelogram a second ago. Here's 2 more pictures of parallelograms on the left. And then on the right, we have things which are not parallelograms. A parallelogram specifically has 2 pairs of parallel sides. So I'll highlight the first pair in green. So there's 1 pair of parallel sides. Here's the second pair of parallel sides. And I really like the name parallelogram, not because I think it's pretty. I actually don't think it's pretty, but what I like about it is it feels to me like at some point somebody wanted to describe a shape that had all of its lines as parallel as possible. They said, geez, what could we call that? What could we call that? How about a parallelogram? That would help people remember. It's so easy to remember. Okay, so that's why I really like that one. On the right, these things are not parallelograms. Now, this first one here, it has 2 pairs of parallel sides, but remember, all these shapes we're learning about are quadrilaterals, and this has 6 sides, so that's not it. This one has nothing parallel, and this one, what's wrong with that one? That's actually a trapezoid. Next up is a rhombus. We have examples of rhombi on the side over here. Rhombi is the plural, by the way. A lot of students will call this a diamond. So if you're thinking, I know that shape is a diamond. Please write something in your notes so you know that instead of saying diamond, even when you mean diamond, instead start saying rhombus. That's much more academic. And that's the name that's going to be used in books and questions, and when you go on to further math, that's always the word we're going to use. A rhombus, if you want to just have the most basic picture, you could draw it like this. A rhombus is a 4-sided shape in which all 4 sides are the same length. And I'm going to write that they're congruent. That's the symbol I'm going to use to express that. Now, looking at the pictures here, you'll notice they have the congruence markers. They also have the parallel markers. So what they're trying to show us in this picture is that every rhombus is also a parallelogram. And that's a natural consequence of having all 4 sides the same length. You automatically get parallel sides. On the right, Why are these things not rhombi? You have two different sides here, so that one's out. What's wrong with this one? It sure looks like a rhombus. But notice, those markings say the four sides, or there's two pairs of parallel sides. We need all the sides to be congruent. And the third one is 5 sides. That's a pentagon. Too many sides. Let's talk about a rectangle. For some reason, when I was young, I never associated the word rectangle with what the meaning of rectangle is. If you write next to the word rectangle, right angle, and if you say it fast, right angle, rectangle, right angle, rectangle, they sound really similar. Not an accident, okay? And while you know what a rectangle looks like already, I mean, come on, you're in high school, of course you know that. You might not know that the definition of a rectangle is a four-sided shape with all right angles. So it has all 4 angles are right angles. That's the definition. The definition of a rectangle actually doesn't include anything about the side lengths. It's just a four-sided shape that's connected by 4 right angles. And that's why it's called a rectangle. And it has the word angle right in it. I don't know if you ever noticed that. Okay, that's a way of remembering it. So these ones, when you draw a picture, I want to encourage you to put actually like that box in yours to show that there's right angles. In this one, and we'll learn later why it's true. If all 4 angles are the same, it does turn out they all have to be 90. We'll learn why in a later lesson. In this second example, they actually did put 90 in all of them, which is nice. What's wrong with the ones on the right? This one has parallel sides. That makes it a parallelogram, but we don't know if it's a rectangle for sure. That's a triangle. What the heck? And then this one, what is that? That looks like it's probably a parallelogram, but yeah, definitely not a rectangle, clearly. The last shape we're going to talk about is a square. I think everybody knows what a square is, or you could identify one looking at it. I don't know if you knew this, you might have. A square is a four-sided shape which has 4 congruent sides, so all 4 sides of the same length, and 4 right angles. Now the thing that's kind of interesting about this, and why we talk about it last, 4 congruent sides, well, that's the definition of a rhombus. And 4 right angles, that's the definition of a rectangle. That's kind of interesting, isn't it? So what that means is that every square, because it has those characteristics, every square is also a rhombus, every square is also a rectangle, and those are both parallelograms, so every square is both a rhombus, rectangle, parallelogram, and a quadrilateral. And they actually took the time to mark that on here. They put markings on our shapes on here. That kind of tell us that. So they say right here, like notice these ones in yellow on the left, those are markings to show that it's a rhombus. The markings in the corners, those are showing, hey, it's also a rectangle, just so you know. And they also included parallel markers. I'm talking about these ones. These parallel markers, those indicate that this is also a parallelogram. It's all of those things. So what about the ones on the right? Why are those not squares? This one's not a square because we don't know any of the side lengths. It's definitely a rectangle. It might be a square, but we don't know. That's a triangle. Get out of here, triangle. This one has 4 congruent sides. It's definitely a rhombus, but it might not be a square. We don't know. They might be off by 1/10 of a degree or something on the angles. To end today's video, I want to invite you to try a question. So here is that question now. Draw a quadrilateral ABCD such that AB is parallel to CD with BC equal to AD. Those are side lengths, by the way. Make sure you accurately mark your figure. What type of quadrilateral did you draw? So, guys, I'd like you to pause the video and try this. Do your best attempt, and then I'll show you what I know to be 2 answers that are right. There's more than one right answer to this, of course. I'll show you 2 different ones. So pause now and then hit play when you're ready. Here are the 2 ways of doing this problem that I'm aware of. The first one is if you draw AB and CD like this, and they said to mark it so that AB and CD are parallel, and they said BC needs to be the same length as AD. That's the first way to draw it. And if you do that, that ends up being a rectangle. The second way I know of drawing it is what if we drew AB a little bit shorter? than DC, because I happen to draw them the same length. So if I draw AB and CD like this, I still need to show that they are parallel. So I'll do that here, parallel. And then when I connect these, oh, except my letters are off, whoops. So maybe some of you caught that, hopefully you did. So A, B, C, D, and then I would still need to mark that these two are congruent. And in that case, I drew a trapezoid. So that's it. Guys, that's all for today's video. Just a whole bunch of vocab and one quick drawing exercise. Hopefully you enjoyed it, and I'll see you next time.